Hey guys, today we're going to be doing the Unit 4 review. Remember that tomorrow we will be having our test over everything that's covered on this review. Okay, so first off, we're going to look at what the graphs of an exponential function and a logarithmic function look like. So starting with exponential, this function is right here. 3 times 2 to the x minus 2 power minus 3. And to save us some time, I went ahead and just inserted a picture of what that function looks like. But you would be able to do this just on a graphing calculator. So first thing I want to do is list any transformations that have taken place. So transformations will be anything other than the parent function. So for this one, the parent function is just f of x equals 2 to the x. I know that because that's the number that's right before the x. So anything else, so there's 3 other numbers, will count as a transformation. So first off, this 3 in the front, that is a vertical stretch. By a factor of 3. Okay, the next thing would be this minus 2 that's up here in the parentheses. Or I'm sorry, there is no parentheses, it's invisible. But that is going to be a horizontal shift. Because it's minus, it is going to the right. So shift right 2. And then last would be the minus 3 at the end. And that's another shift, but this time it's going down 3. So 1, 2, 3 transformations. Next is the asymptote. The good thing about exponential is it's always a horizontal asymptote. So horizontal. So it's always going to be y equals. All we have to do is figure out what number. But if you look at the equation, it's always going to be that last number, however much it moved up or down. So if you look at the picture, that's 3. So our asymptote is at negative 3. Y-intercept. So you can clearly see it from the picture. It's about right there. So it's a little bit past the negative 2. But if you wanted to actually figure out what the number is, you would plug in 0 for x and solve this. And it turns out to be negative 2.25. So our y-intercept is 0, comma, negative 2.25. Domain and range. The domain of an exponential function, so domain means side to side, it's going to keep going forever to the left and forever to the right. So domain is negative infinity all the way up to positive infinity. Range is where it does have a stopping point. So on the top, it is going to keep going forever. But at the bottom, it doesn't go past that asymptote. It just gets really close to it, never crosses it. So range is going to be from negative 3 all the way up to positive infinity. Then end behavior, meaning the left and the right side of this graph. On the left side, that is where x approaches negative infinity. Well, the function, you have 3 options. Either it goes up, it goes down, or it stays flat. In our case, it's going to stay flat. So we have to say exactly what number that is, and that is at negative 3. On the right side, that's when x's are approaching positive numbers. Our function, it's a little clearer to see, is going to go up, so positive infinity. You need to be able to identify all of this information about the graph of a function. So it's easy just to graph the equation and put it into the calculator so you can see your picture. And for the most part, I believe if you press menu 6 for analyze graph, most of these will be options that you can click on. Okay, but you also need to do the same thing for a logarithm. So here, this logarithmic function, the parent function would be just log base 3 of x. So anything extra is going to be a transformation. So in this case, we have 2 things, that plus 4 and the minus 1. Plus 4 is inside parentheses. That means that it is a shift 4, and it's plus, so it's going to go to the left. And then the minus 1 is shift 1 down. Okay, asymptote. So because logarithms are the inverse of exponential, everything's going to seem like it's opposite. So this time around, our asymptote's going to be vertical, which means that it's going to be x equals. And it's always going to be the number in the inside of the parentheses, only opposite sign. So I know this is plus 4, but our vertical asymptote's going to be at negative 4. And you can see that from the picture as well. Okay, y-intercept. So you can see from the picture that it is crossing. I'm sorry, this should have said x-intercept. X-intercept. You can see from the picture that it's crossing right here. That's at negative 1. Okay, domain. So this time, on the right side, it is going to keep going forever, but on the left side, it never crosses this dotted line. So it starts right here at the negative 4 and keeps going until infinity. Range is up and down. It points down, and this is going to keep going up. So this time around, it is all real numbers, so negative infinity to positive infinity. End behavior. So on the left side, x is not going to approach negative infinity because it, like we talked about, it's never going to pass this line. So what you're going to say is as x approaches that line, which is negative 4, our function goes down, so negative infinity. Then on the right side, as x approaches positive numbers, the function is also going to go positive. So I believe on the test you have one question on each type, and it's not going to ask you for all the information. It's going to pick one thing. So for instance, it's going to say, what is the end behavior of this function? Or what is the asymptote of this function? But you need to know how to find everything just in case they ask you something different. Okay, the rest of this is a lot of solving. So I think the rest should be a little easier. So starting with logarithms, you need to be able to convert between logarithmic form and exponential form. So for instance, this first one, it's a logarithm. We want to write it as an exponent. So what we do is we start with the base. Always, always, that's going to be our first number. But the other two switch places. So this will become an exponent, and what's in parentheses becomes the answer. And you could always check your work by seeing if this is an actual true statement. If you type in 3 to the 4th power, does it give you 81? And in this case, it does. Okay, but now we need to go, well, I'm sorry, let's do one more like that. This is natural log. So remember this ln, that's just a fancy way of writing log base e. So these are exactly the same. It's just that this is a little bit of a shorthand. So now when we rewrite it, the little number, the base, is still going to be the first thing we write. X will be our exponent, and then 2.5 becomes our answer. Okay, now we want to actually evaluate. So yes, this is a little bit of a cheat. You could just type this whole expression into the calculator and you'll get an answer. But really what you should be doing is converting it to exponential form. So 5 would be the first. We don't know what it equals, so we're going to call that x. And then equals 625. So when we're finding a logarithm, what we're doing is thinking about what power do I have to raise 5 to in order for it to become 625? So I'm just going to do a list. 5 to the 1 power is 5. 5 squared is 25. 5 cubed is 125. 5 to the 4th power is 625. So there we go. 4 is the number that worked. So evaluate that expression. Well, it equals 4 because that's the exponent that works. Okay, let's do another one. This time I put it as a fraction so we can see the difference. So we're going to do 4 to what power would give me 1 over 256. So we're going to need powers of 4. Well, 4 to the 1 power is 4. 4 squared is 16. 4 cubed is 64. 4 to the 4th power, that is what gives us our 256. Only that's 256. I want it to be 1 over 256. So this exponent, you're going to make it negative. So this would be negative 4. Okay. For these, we are going to condense and expand the logarithm. So there's 3 properties that you really need to know. Product property. So when you are adding 2 things that are log, when you combine them, you could just multiply. There's quotient. So in this case, it would be subtracting x over y. And then there's the power property. Which states that if you have a coefficient out front, you could just write that as an exponent. Okay, so right now I have 2 different logarithms here. We want to combine them into one. So I always do any numbers that are out front, we're going to make them into exponents first. So log base 3 of x to the 4th minus log base 3 of y squared. So just those coefficients became exponents. But now, because it's subtraction, that is the quotient property. So when I put these together, be careful that the first one goes on top and the second one becomes the numerator. And that's it. That's the final answer. It is now 1 logarithm. But you also have to be able to do this in reverse. So that's what this one is. Completely expand the logarithm. It is 1 logarithm right now. I want to completely separate it. So there's a 5, there's a u, and there's a w. So that I know that this one, when I fully expand it, needs to be at least 3 pieces. So start with the most obvious thing, that fraction. So numerator will be 1, denominator will be 1. But when I separate it, so here's my numerator. And then here's my denominator. Since it's dividing, that is quotient property, you need to subtract. Okay, but then this one is just a w, so that's fine. But this one over here is actually 2 things. It's the 5 and the u. So I need to separate them out. Okay, but, oh, I'm sorry, this should also be underneath. Okay, but since they are multiplying, they're right next to each other, that is product property, we would add. Last thing is power property, and it turns out all of them have it. So square root is just another way of writing to the 1/2 power. And both of these have that. So that means that we need to have that for each one. So 1/2 log base 2 of 5, not underneath the square root anymore. Then 3/2 log base 2 of u, also not underneath the square root anymore, minus 4 log w. Okay, the rest of these we're going to need a calculator for. On this one, solving logarithmic equations, there's always 2 different types for log. This first one here is when it's log equals log. In my opinion, these are easier. As long as they're all the same base, so 4, 4, 4, you could just combine. So right here, plus sign is the product property. So that means that I would have to multiply these 2 things. And on the other side, nothing yet. Okay, let's distribute. So 5x minus 10 equals 14 minus 3x. Let's get all of our x's over to the other side. So I would have to add. Then let's add 10 to both sides. 8x equals 24. Then last is to divide by the 8. 24 divided by 8 is 3. Number 10 is still logarithmic equations, just this one's a little different. This is when log equals a number. So you still want to isolate the logarithm, which means that this 11 needs to go to the other side. So now I have log base 3 of 2x plus 1 equals 2. But from here, since the other side doesn't have logarithm, we're going to convert to exponential form. So that would be 3, because you always start with the base, to the second power equals 2x plus 1. Well, we all know that 3 squared is 9. And then from here, it's just a two-step problem. Subtract the 1. 8 equals 2x. Then divide by 2. So x equals 4. Okay, next is exponential. Again, exponential has a bunch of different types. So in this first one, you need to make sure that they have a common base. So in this case, I'm going to highlight the bases. We have 8, we have 1/2, and we have 1/4. So obviously right now they don't have the same base, but I know that I can make them all have a base of 2. So powers of 2. So y'all can see. So 2 to the 1 is 2. 2 squared is 4. 2 cubed is 8, which all three of those numbers, 2, 4, 8, show up in those bases. Now these fractions just mean that we're going to have a negative exponent. So I'm going to rewrite 8 as 2 to the third power, but remember it still had that 3x, so that needs to be there. Then 1/2, I'm going to write that as 2 to the negative 1 power. And then it had our x plus 2. And then last, that 1/4, we're going to write it 2 to the negative 2 power. And then 2x minus 11 was already there. So now they all have the same base of 2. So now we can use our product property here that says that when you are multiplying, you could just add up the exponents. So this would be, well, I'm going to distribute. So that's 9x. And then here, distribute the negative 1. So minus x minus 2 is equal to, and then I'm going to distribute over here, negative 4x plus 22. And then now we just solve. Let's combine these. So that's 8x minus 2. Let's make it to where all the x's are on the same side. So I'm going to add 4x to both sides. 12x minus 2 equals 22. Let's add 22, or I'm sorry, add 2 to both sides. I'm running out of space, so I'm going to write over here. 12x equals 24. And last step is to divide by 12, so x equals 2. So you have to have a common base when solving these. The next one, the bases are different, 5 and 3, but this time around there is no way to make them have a common base. They do not have common powers. So when this happens, you start off by taking the log of both sides. Then you can use the properties of logarithms to help you solve. So for instance, I know that whenever I have an exponent, I can move it out front. And I'm going to do that for both sides. Okay, then, this is just regular multiplication. I'm going to distribute the log 5 and the log 3 to both things that are in those parentheses. Now, anything that has an x, so we have two things, right here and right here, we want those to be on the left side. Anything that doesn't have an x, we want to move to the right. So this would be 2x log 5, and then I'm subtracting the other one, so minus x log 3 is equal to 7 log 3 minus log 5. Now, X is in two places, and I only want it to be in one, so we are going to factor that out. And then they are being multiplied, so if I divide by that, it will cancel it out. And what I do to one side, I have to do to the other. And that is what's going to give me my answer. So all I need to do is type this part into the calculator. So I have a calculator right in front of me. Let me get the answer for you guys. This is going to be 2.868. Okay, and then last but not least was our word problems. So Sharon invests $2,300 into an account that earns 4.25% interest compounded weekly. Find the balance in 18 years. So since it's compounded weekly, we know that N is going to be 52 because there's 52 weeks in a year. 18 years is our time. This right here is our rate. And this is our initial amount that we put in, so our principal. So we're using this equation. We just got to fill in everything that we have. So principal was 2,300. 1 plus 0.0425 over 52 raised up to the 52 times 18. And then all calculators. So let me put this in the calculator for us really quickly. And I get, so this is money, it's balance. So $49,411.43. Okay, so now let's look at another word problem. It says Kevin starts a new job with a salary of $26,550. If he gets a 3.5% raise each year, how many years will it take for him to have a salary that exceeds $46,000? So in this case, we're going to use regular exponential growth. So that is f of t equals a, parentheses 1 plus r raised up to the t power. Now we're going to fill in everything that we have. His initial amount was $26,500. I know that it's plus because it's a raise. 3.5% would be 0.035. It's asking us how many years, so we actually don't know how many years it's going to take. But they want it to be 46,000. So we need to solve for t. So this is where we have to use logarithms. First, let's divide both sides by 26,500 so that can cancel. And let's add what's inside the parentheses. Okay, so let me find out what that part equals. So that one, it's a kind of an ugly decimal, so it's better to leave it as 92 over 53. The calculator simplifies for you. Now we're going to take the log of both sides. And using properties of logarithms, anytime you have an exponent, you can move that out front. And then if I want to solve for t, I need to divide by this logarithm. So this is what we need to type into the calculator to get our answer. So let me do that for us right now, and I will tell you what I get. Okay, so I get 16.031. But these are a little bit weird. So it's asking how many years will it take for him to have a salary that exceeds 46,000. If you just type in 16, like if you plug in 16 to see if it works, it's going to be about 45,000 something. It'll be really close to 46, but not quite. So in this case, you have to round up no matter what your decimal is. So we would say that it's going to take 17 years for it to exceed 46,000. Okay, guys, that is it for the review. We're going to have our test tomorrow, and just message me or email me if you have any questions. Bye.